Well, I got about 10 minutes of lunch break. Let's see what I can get done here. So this is factor and solve, find all the complex zeros, and you've got the patterns there off to the side. So this is a 2x that's cubed. And this is a 5 that's cubed. So A is 2x and B is 5. So we're going to use that sum of two cubes formula right there. We'd have 2x plus 5, parentheses, I square, 2x times 2x is 4x squared, minus because there's a minus, 2x times 5 is 10x, plus because there's a plus, 5 squared is 25. Still equal to 0. You get this guy for nothing. That's negative 5/2. That's your real one. And then you're going to have to do quadratic formula on the next one. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Lost my place there. All right, so 10 squared is 100, and we're taking away 400. That's root of negative 300 over an 8, and we also have 10 over 8. 300 is going to be 100 times 3. Of course, it's imaginary. It's the imaginary root of 100 times 3. So it's 10 root 3. All right, so 10i root 3 over an 8. And we can simplify that sum. 10/8 is going to be 5/4. So 5/4 plus or minus 5/4 of I root 3. There's number 2. It's not that bad. 3, using synthetic division and your graphing calculator, find, I'm just going to switch over to Desmos real quick. So I don't feel like pulling out the Wabbit email. 2x to the 5th plus 3x to the 4th. Fourth minus 30x cubed. Well, I spent some time making this problem. Minus 57x squared. Minus 2x plus 24. Well, looky there. There's actually a couple of nice zeros. Actually, they're all up. I knew I'd have some bad ones. See these guys right here? They're radicals. So I need those. So I've got negative 1.5, negative 1, and 4. Those are my 3 nice ones. I'm just going to do some synthetic division. 2. Do I need any placeholders? No. 3. Negative 30. Negative 57. Negative 2. And 24. Your acronym for this was drop, multiply, and add. I'm going to do the negative 3/2 first. That's what negative 1.5 is, by the way. So the 2's would cancel. Negative 3, we get a 0. Anything times 0 is a 0. Negative 30. This would be 90 over 2, which is 45. Negative 57 plus 45 is negative 12. This would become 18. That's going to become 16. And that's going to become negative 24, and there's your 0. Because you got a 0, you get to continue doing synthetic division with the new number set. This time I'll do the negative 1. It doesn't really matter which ones you do in order. Anyways, I'm dropping, I'm multiplying, and I'm adding. There you go. Going to do it again one last time. This time with the 4. Drop the 2. 4 times 2 is 8. Negative 2 plus 8 is 6. 4 times 6 is 24. Negative 28 plus 24 is negative 4. 4 times negative 4 is negative 16. I got a 0. Remember, remainder constant xx squared. I have 2x squared plus 6x minus 4 equals 0. I'm going to pull a 2 because I can, not necessarily because I should, but because I can. Because this makes the quadratic formula's numbers smaller. That's why I'm doing it. And then I'm going to do the QF. So x equals negative b plus or minus square root b squared minus 4ac -2. All over 2a. So 4 times 1 times -2, that's going to be +8. 9 plus 8 is 17. And both pieces are over 2 because 2 times 1 is 2. And there's that ugly decimal that Desmos was showing us. That's what those guys are. And moving forward. I don't really know that it matters which ones of these I do. I'm just going to do number 5. 5 is a 2-step. We're going to add 6. That's going to give us -14. We're going to divide out the -4. So root x is going to be 7/2. Now the opposite of square rooting is squaring. That's going to give me 49/4, but I have to include the plus or minus symbol. So x is plus or minus 49/4, and you're supposed to check your solutions, okay? Because you might have an extraneous solution. We'll see. -4 times the root of 49/4 minus 6. That's -4 times 7/2 minus 6. That's -28/2 minus 6. That's -14 minus 6, which is -20. This guy passed out. Now the next one is saying let x be negative. And I know real quick that this is imaginary. So the real is x equals 49/4, and the imaginary is x equals -49/4. Yeah, that was easy. They're all about the same difference. Let's do 7. Now, we're going to end up taking an odd root, so we're only going to have one answer. You'll see that in a second. We're going to add 73. That's going to give us 243. So x minus 5 to the 5/3 is that. And we're going to counteract the 5/3 with the 3/5 power. Gone. Now, this is the 5th root of 243 cubed. There's only one solution, okay? Because 5th root, 1. Just one thing. So the 5th root of 243 is 3 that I cube. X minus 5 is 27. So x is 32. Easy peasy lemon squeezy, right? Now, 8 is a solve for y. A little harder to do. But I want to get that y guy all by itself. So the first thing I'm going to do is I'm going to fix that multiplication. That'll free up, drop the parentheses, divide everything by 3. X over 3 is the cubic root of 15 plus y. Now the opposite of a cubic root has got to be to cube both sides. You can only do that when there's one thing on the left and one thing on the right. That's the only time you can do it. Plain and simple. So I just cube both pieces. That's x cubed over 27, and that's equal to 15 plus a y, and then I subtract my 15. And I am done. Easy peasy lemon squeezy. 10 is probably the hardest one on here. Maybe I can get it done by the time lunch break is over. You've got a cubic root there, so what you're going to have to do is you're going to have to cube both sides. And you're going to have to write that bad boy out 3 friggin' times. And it is not going to be pretty. All right, so we do some of the foiling here. We're going to have 2x squared minus 4x plus 1. And we still have 2x minus 1 to work with. It's going to be the distributive property. 2x times 2x squared is 4x cubed minus 8x squared plus 2x. Now I'd use the -1 minus 2x squared plus 4x minus 1. So that's 4x cubed. Looks like minus 10x squared plus 6x minus 1. It's still equal to 8x cubed. Oh, that's a 4. Oh, man. That's a 4. Something wasn't working. Do that again. Distribute the 2x, 8x cubed minus 8x squared plus 2x. I distribute the negative 1 minus 4x squared plus 4x minus 1. All right, cool. I was worried because I knew some stuff was supposed to cancel out. There's minus 12x squared plus 6x minus 1. So there's things that are in balance on both sides. I'm just going to throw them out the window. 0 equals negative 12x squared plus 6x. This is factoring 101. Let's just jump everything to the left to make it positive. It'll make the factoring more apparent. Both pieces contain a 6x. If you pull a 6x from 12x squared, there's a 2x. If you pull it from itself, there's a understood 1. So x is 0 or x is 1/2 because I know how to use the ZPP. And then I go see if I go through and I see if these things make sense, okay? So if I take the cubic root of 8 times a 0 cubed minus 1, I'll have the cubic root of negative 1, which is negative 1. On the right-hand side, that was plugging in a 0, I get negative 1. So they match. It's true. They work. If I plug in a half, I have the cubic root of 8 times a half cubed minus 1. A half cubed is an eighth. 8 times an eighth is 1. So I have the cubic root of 0, which is 0. And if I plug in a half on the other side, I also get 0. They are both real. Well, there's still 2 more I'd like to do, but that's 2 less than I had to do. Notice I'm working on lunch.